Hello everyone. This is another question that is related with the geomorphology. And in geomorphology, it is related with the river morphology. Okay, so this question is also an interesting, and from this single question, there are so many things that your things are getting clear. And apart from this, if you have any other question related to this, you can ask me in the comment box. I will try to solve those questions also. Ask question to the system from where you are learning, and don't wait for the opportunity. Okay, opportunity will come and go. If you are ready, you will crack. Okay, so don't wait. Okay, and from this simple question, how we will read this graph and what are the terms in this, we will understand those things. Okay, and accordingly we will reach to our answer. Okay, as such this question is not that difficult. Okay, only the terminology that are given in this we will understand that, and try to read the graph. Okay, and we will use our basic knowledge also. Okay, how we are seeing the things. Okay, suppose this is our basin. Okay, from within this, suppose this is our basin, we call it as a watershed. Also we call it as the catchment area. Catchment area, and we also call it as the drainage basin. Okay, this question already came. Okay, this question already came. Okay, in some UPSC exam. Okay, so this boundary that demarcate the catchment area, we call it as a watershed. We call it as a basin. Okay, so now within the basin we are getting some streams. Okay, suppose this is and apart from this, what are the things that we needed in this basin? Okay, to solve a question. Okay, this is the question. Okay, we need to know about stream order, numbering of stream, channel length, mean value of basin area, and gradient. All these things we have to know, and we will add all the information. Okay, I will add all the information one by one. Okay, first we will go to see, these are the some of the river morphology part. Okay, there are so many other things. Okay, related with the river morphology part. Okay, if you need a single separate video on river morphology and some competitive exam with this in that single video, you can mention in the comment box. Okay, because to make one single video it will take time also, and whoever is needed I will prepare accordingly now, according to your concept. Okay, so now first is our stream order. Okay, but before stream order we should know how to give numbering in the streams. Okay, suppose this is our some streams. Okay, suppose this is our from the beginning of the stream now, we call it as a first order stream. Okay, we call it as a red one is our first order. Okay, first order stream, we give this number this stream in the beginning. Before it join with other stream now we give it a one number. Okay, So all these are 1 1 1. I will change the color. Now this is our second order stream. Okay, after joining of these two, now we are getting second order stream. Okay, so this is also second order stream. Okay, where our two second order streams join. Okay, we'll get a new one. We get a new one. Okay, that one is our third order stream. Okay, I will construct more. Okay, so that your concept will clear. Suppose this is our one more first order stream. Okay, now so these two first order again will join. Okay, and this green one are second order. Okay, now this will join with this here. Okay, this one is our, this color is our, blue one is our third order. Okay, now suppose this is our first meet. Now we'll get second order here. It directly meet with third. Now here numbering is not getting changed. Okay, numbering is not getting changed because second order is joining with third order. If same order will join, a new order will come. Okay, otherwise the previous one is carrying on. Okay, the higher one is carrying on. Okay, like this is first, we'll get second. This is first, we will getting where our second order will meet, we get a third order stream. But now our this second order is meeting in third, so we will give a higher number. Okay, already third order it will go. It is second. Okay, this one is, this green color is second. Okay, but this one is our third order. Okay, now here our third order is meeting, and we'll give another color. We will leave this color. This is now our fourth order. This color is now our fourth order. Okay, in this way we are giving numbering as well as order. Okay, our numbering start from the origin, from where the stream is originated. Okay, we give one number to that stream. Okay, once that at one place it is started here, it is started here. Once they meet, both will meet now, our first order will end up here. Okay, and second order will start from that place. I will add more information. Suppose our first order is meeting in our second order stream. Okay, the order already make two now, so it will only one. Okay, but it will continue the second one. Okay, one meet we will get two. Okay, in a similar way we are getting two, we will get a three. Okay, in this way. Okay, so now suppose one first order stream is involved, one first order stream is joining in this fourth order. Our order is, this is first order, this is fourth order, it will continue. Okay, suppose our second order stream join in this fourth order. Okay, order is not getting changed. Okay, it is second order joining in fourth one. Okay, because the higher order is already made by joining of second and this now, so it will continue. Okay, at this place we will call it as a second order join in fourth order, and fourth order will continue. Okay, Unless one fourth order stream will not join, it will not go up to 5. Okay. Suppose there is one more basin. Okay, like this. Okay, and we are getting a. I'm not constructing other one. Okay, I'm constructing this one. Suppose fourth order is coming out from this one. Now this fourth and fourth order will join. Now this is another basin. Okay. Now this fourth and fourth will join. Now we will make one more new order. That is our fifth order. Okay. In this way, we are giving the numbering as well as the stream orders. Okay. Now channel length. Channel length is the total length of these. Okay. In a similar first order, I have some length. Okay. Some length. Okay. In a similar way, second order have some length. That green one. In a similar way, third order will have some length. Okay. And fourth order will have some length. Now, what is the relation of first, second, and third and fourth? Either these lengths are increasing or decreasing. We will understand that. Okay. While graph reading, we will understand that part of it also. Okay. Length of the channel is this. How much kilometer this first order will add? Okay. This all we will add. This red all we will add. Okay. This is our fifth order. In this way we are making. Okay. This is our fifth order. This one is our fourth order. This one is our third order. Okay. This green one is our second order. And this red one is our first order. All are first order. Okay. This red. One will join and two will make. Okay. And second order will join, third will make. And in higher order, if lower order will add, our next order will not change. That mainstream order is not getting changed unless the same order is not joining in this. Okay. So this is the way. Okay. And we will calculate our length by adding total stream length. We will calculate. We need to calculate. We will add all. Okay. And single also we will calculate. Okay. Now mean value of basin area. Okay. Mean value of basin area. This first order will have some. Now I will complicate this. Okay. I will not complicate this. I will just go to this part. Okay. Single drainage basin. Okay. This blue line have some area. No? This blue line have some area. In a similar way, this third order have some area. That green one is also have some area, and this first order also having some area. All have separate area. No? All have separate area will come. No? For everyone, separate area will come. By software will calculate this. Okay. And this is for our stream channel length. Okay. And suppose this stream has some area. Okay. And this third order also have some area. We will add all the values. We will get the mean value of the basin area. We will add our all values of first order area, second order area, third order area. We will get the total value of the basin area. Mean basin area having a formula of area of all basins. I will explain. Okay, wait. Area of all. This is just a total of all the basins area. Okay. With first order means this first order how much is the area. Okay. I will explain. Okay, more. And number of basins. Number of basins. There is one in this. There is no stream order. Means stream order. With respect to stream order, what is the formula? Average area. Average area of all basins. Divided by particular stream order. Stream order. What does it mean? Okay, now to calculate any means we have to calculate for the fifth means first order area. Okay, first order area have small basins. This is the overall watershed or catchment area, but here we have a single basin also no? For first order itself, like this. Okay, in this way we are having. Okay, so area of all these basins we have to add. Okay, and average out that. Okay, we will get our means area of all basins. Suppose this is first order area of all the first order basin. Okay, and divided by number of basins like 1 2 3 4. Like suppose I have this much now. Suppose 1 2 3 4 5 6 7 8 9 10 11 12 13 14. Small means number of basins. Okay, for first order. Okay, and total area is something. Okay, suppose 100. So if we will divide this, we will get our mean basin area for first order. Okay, in the similar way we will calculate for second, third and fourth and fifth order. Okay, okay, this is the way to calculate the mean basin area. Okay, now our little bit. Okay, now we will one thing is remaining. Okay, now that is gradient. Okay, gradient is what for first order stream gradient will be high, and as it reaches to the fourth order, fourth to fifth order, its gradient is getting low. Its grading is getting low, but grading is not getting low which suddenly. Okay, it is not getting suddenly. Okay, because we have to maintain our stream course area also. Okay, equilibrium profile also. There is one equilibrium profile in this. Okay, we have to maintain that one. Okay, our equilibrium line will be disturbed when sea level is getting rise or load. Okay, due to that nick point will come. Okay, in the case. Okay, I will not go in that one right now. uh, if you need a full video on this and topic you are facing difficulty, you just mention in the comment box, so we'll try to make that video on that. Okay, because everything is interlinked with one another thing now. So slowly I will try to give you the best. Okay, so now we will read the graph now. Most of the things we have done, and we will read the graph and understand these things in much better way. Okay, how we will read with respect to graph also now. Okay, so and we have to read graph with respect to what? I will we will read all the four curves, okay, that are given to us now. After that, we will go to our options, okay. See this stream length for a single stream order we can also calculate, okay. We'll add all the values and divided by the number of streams, okay. In this way we will calculate for means channel length also, okay. So now with respect to graph, okay, we will understand all the things, okay. And why this A curve is for why this A curve is number of stream with the relationship to the stream order. Okay, see if we look at in our diagram, in first order we are getting how many streams? Okay, in second order how many? Number is getting reduced now. Okay, so in a large basin, okay, this basin is very small. I just to make that in first order streams are more. Okay, in second order streams are getting lower, but there is some relationship. Okay, in that way the streams are getting decreased. Okay, and one more thing is, I will write one thing for this. This stream order is in arithmetic scale. Okay, and this side it is logarithmic scale. Okay, so now in first order, suppose we have how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So we will consider it in a thousand. Means 14 is there now. First order, okay, I will write. Okay, 14 in second order, 1, 2, 3, 4, 5, 6. We are getting 6. In third order, how many? We are getting 2. And fourth order, we are getting only 1. Okay, and suppose I will, this is small basin, I will multiply with this and make it in thousand. Okay, I will add 20. Okay, I'm just increasing the number. Okay, 600. Suppose it is 20, and it is 1 only. Suppose. Okay, so now in our first order we are getting how many? 14,000. Or I will means we have to just match with this data. Okay. So our graph will become like this. If I will consider 14 here and 600 will be here. Okay, suppose this is our 14. 600 will become here. Okay, and then 20. 20 will become little more than 20 will become. Okay, this is our 10. Suppose this is our 20, no problem. And then first one, suppose. So our curve will be like okay. Numbers are not accurate, that's why this curve is not that accurate. Okay, so now with our new curve is matching now that we have prepared. Okay, in A, with the decrease of number of streams of in first order to second order, our order is getting increase. Streams are getting decrease, orders are getting increase. So if stream order is increase, okay, our number of streams getting decrease. Okay, and this is represented by curve A. I will prepare a small graph for this. This is a case. Why not D is representing this? Okay, Why not D is representing this? Okay. See, in D, okay, number of streams are suppose how many? 8. Number of streams are suppose 8. And in second order, how much it is? Suppose 7. And third order, how much it is? Suppose 6 and 5 and 4, suppose, or 3, like that. Okay. So if we go into over this, okay, in first order, okay, this much streams is needed now. If we have to reach up to fifth order, na, if we have to reach our fifth order, how much first order we will need? They have reached up to fifth level. How much first order we will need? We will just need only, we will just calculate those which are connecting and making 2. Okay. Here, what this and this will join and make 3. To make 3, we have one more 3 na, to make 4. Okay. So how many? 1, 2, 3, 4, 5, 6, 7, 8, 9. I will not calculate this. Okay. 9, 10. Minimum 10 is required to make fourth order. Minimum 10 is required for making fourth. Fifth will not make here na. I will have one more fourth order, then we will make fifth na. So this is for what? This is our, with respect to stream out, it is not matching. Okay. With respect to gradient, it is going good. Stream gradient is not getting that steep. Okay. Slightly in first order we have some gradient. In second order, okay, our slope is getting lower. That's why water is flowing like this now, from original, from here to fifth order. Here gradient is high, here gradient is low. Okay, not with respect to stream number it is matching. Okay, with respect to gradient it is matching. Okay, again lower, and again lower. Okay, so stream order is getting increase. Number I'm talking. Okay, not the values. Okay, stream getting is like first order, second order, third order. Okay, in that way. If stream order is getting increase, our gradient is getting decrease. That is represented by our curve D. Okay, like this. Now channel length is, for first vector we have to calculate some channel length, and means average of all the channel first order channel length and divided by the number. We will get some number. In the second order we will get in the same way, in the third order we will get in the same way, and fourth order we will get, and how much is the order we will get in that way. Okay, and total of that we will get the whole basin length. Okay, so in every step our channel length at addition of all the things na, so our total length is getting increase in every step. Okay. Okay, so with the increase of stream order, our channel length is also getting increase. Okay, and it is represented by B or C, both are increasing now. Don't go with these numbers. Okay, 1, 10, 100, 1000. Okay, this side they are also given now. We have to think with respect to this. Okay, not with respect to this. Okay, always think in this way also. Okay, so curve B and C will be the case for this. Okay, now with respect to stream order, if the stream order getting increase, area, basin, mean basin area is also increasing with this. Is okay, it is having some area. We'll calculate by getting average. Second order also have some area. Okay, same way, total area divided by the particular means number of basin in that first order. Okay, in a similar way we'll getting. So now in every step, suppose it is 100, it is around 50, So our graph is getting increased. Our graph is getting increased with respect like this. Suppose this is our basin area. Okay, and this is our stream order. Here we are getting 100, 200, 100, 200, okay, 300 in this way, suppose. And in first we are getting 200 area. I will make it less, okay, 50. Suppose our first order stream having total area 50. So our graph here we will get in second order some value will be added. Suppose now it is making 100. Okay, this is our second order, third, fourth order in this way. In the third order, the number is getting increased. Suppose 150. Because okay, and in fourth order again, and we will get a graph like this. Okay, for this stream length or channel length or and for both the things. Okay, so now for B and C we will say that. Okay, B and C, for P and C we can say that with respect to stream order, our channel length and this mean basin area is getting increased. Okay, so I'm not separating these two. Okay, B and C will represent both. Okay, but we can say that our channel length can be, now if I want to distinguish which one is B will represent our channel length or this mean value area. Okay, we'll start our length from 0. Basin area cannot be 0, no? Okay, so C will represent channel length and B will represent in general. Okay, mean basin area, and this A will represent what? Our, I will remove this. Our A will represent this number of stream, and this D curve will represent gradient. Okay, now we will go to our options and we'll try to find the answer. Okay, now we will get easily. Okay, but apart from this, okay, this river morphology, there are so many other things that we have to learn, like I will write where, I will write here. Okay, bifurcation ratio, okay, seniority index. Okay, and with this we have a drainage density. Okay, and one more important thing is that hypsometric analysis. Okay, that is very important. Okay, that question already came. Okay, there are so many things. Okay, if how much is the, what is the rock that present within the basin, accordingly our drainage basin outletting water flow will be changed. Okay, so if you want to learn that thing also, you just mention. Okay, because question related with that also already came. Okay, so now this question is already getting too long because lot of information is there, okay, within the single question. Okay, so I cover most of the things. Okay, but within because within a single video to make it means add all the things will make it this question clumsy. Okay, so I will not going into that. Okay, so now with respect to this we will understand most of the things. Now we will go to our answer and find out that. Okay, so in our question, what they are asking for us from us, identify the lines that correctly represent the relationship of stream order with number of streams. We have to find out the which are the curves which are representing the streamlines and number of stream. Number of stream is and stream order is given by this curve A. and for gradient, which curve? This D curve is representing that one. Okay, so our answer is A and D. Okay, instead of gradient, if they have written something else, so then our answer is getting changed. Okay, with respect to what they are asking, we will. Okay, so now if you have any other question apart from this, you can ask me, ask from the system from wherever you are learning. And if you have any query, you can ask me in the comment box. Okay, and hope you learned something from this video. Share this video with your friends so that they can also get benefit, and discuss among each other so that our concept will be more enhanced. Okay, and don't wait for the opportunity. Okay, opportunity will come and go. Thank you.